So this is a supplementary math lesson covering lesson 64A for Algebra 2, complex fractions. If you want to turn in your textbook to page 262, and I'm going to be going through example 64.2 at the bottom of the page. So if you want to pause the video and open your books to page 262, do that now. Okay, so the book defines a complex fraction as a fraction that contains more than one fraction line. What does that mean? It simply means we have a fraction over a fraction. Okay, in this case, a over x is a simple fraction. We just have one expression in the numerator and one in the denominator. Okay, this here is a complex fraction. Okay, we have one expression in the numerator, but in the denominator we have another fraction line right here. We have a fraction within a fraction. Okay, we have a fraction within the denominator. Okay, now this is nothing new. Now I realize it's been a while since we've actually done complex fractions. I was like, man, when have we done that? So I went searching back through the book. It was way back in lesson 33 was our last lesson in complex fractions. Okay, so but let's just review real quick. It's nothing new in algebra. It's stuff that you've been exposed to even at the grade school level. Okay, we've had problems like this. Okay, 4/7 divided by 1/3, and we know we don't like to divide a fraction by a fraction. Why? We have a complex fraction then. Okay, we have a fraction in the numerator, a fraction in the denominator. Now, in grade school you said we don't like to divide it. We much rather multiply by the reciprocal to get our answer here, in this case 12/7. Okay, so if we express it as a complex fraction, the 4/7 divided by 1/3, we can see we have more than one fraction line. Okay, we actually have three fraction lines. 1, 2, 3. Okay, and in this case, they're either going to ask us to simplify or to express it as a simple fraction. Okay, a simple fraction being one term in the numerator, one in the denominator. Okay, so we see here with a complex fraction, the procedure is the same thing. We're going to multiply by the reciprocal in the denominator. Effectively, it eliminates the denominator then. It cancels out. And we must multiply by that same thing up in the numerator. Okay? We're multiplying by the reciprocal, and it comes out to 12/7. Okay? So it's going to be the same drill with these more complicated complex fractions that involve numbers and variables, with the letters. And so just let your eye be the guide. Okay, what looks to be the problematic area, the complex area of this fractional problem. Okay, this one doesn't give us too much problem. This one does, and where is our eye drawn? Okay, and maybe if you don't like these problems, maybe it's not drawn to there, it's drawn away from there, but we recognize this here expression in the numerator is problematic. Okay, and again, mathematicians don't like final answers where there's a fraction in the denominator. So for two reasons, we see this is the area that is problematic to us. That's the area we're going to attack first. So we're going to combine that into one fraction with a common denominator. The common denominator will be x. Okay, so this denominator is missing an x. Okay, I'm going to put x in there, and I'm going to multiply by x in a numerator to get the same expression. Okay, so that changes the numerator for this fraction into x. This fraction already has an x in the denominator, so I just simply bring that numerator down with it. Okay, and that's still all going to be divided by that 4. Okay, we haven't done anything with the ax over here. Okay, now that we've simplified this into a simple fraction in the denominator, we have one expression in the numerator, 1 in the denominator. How are we going to get rid of it? We're going to multiply it by its reciprocal. And whatever we do on the bottom, we must do on the top. Okay? And let me make this line a little bit longer. Okay? So effectively, what does that do? The x's cancel here in the denominator. The x plus b cancels in the denominator. We are left with the 4 times this expression in the numerator. So that's going to give us ax. Again, we haven't done anything with that ax yet. Okay, it's going to give us 4 times x in the numerator, 4 times x, and an x plus b in the denominator. Okay, so now it's starting to look a little more simplified. Now we just have to simply, and I'm sorry, these expressions are added here, not multiplied. So now we just have to simply combine these two fractions, just like adding a fraction, you know, 1/3 plus 3/6. How do we add them? Well, we first have to combine them into a common denominator. Okay, the common denominator in this case is going to be that variable x, and we also have an expression that's added. Okay, so that's going to be part of our common denominator. X plus b. That is going to be our common denominator. Okay, so what is this fraction missing here? It's missing an x plus b. So we're going to multiply that x plus b. And we do that on the top as well. X plus b. Okay? What does this numerator change into? And I'm sorry, let me just move the screen down a touch so you can see that bottom line. Sorry about that. Okay? It's going to be an a times an x plus b. Okay? And then what is this fraction missing in the denominator? Well, it's missing an x. So we're going to multiply by an x, top and bottom. Okay? This term up here becomes 4x squared. Okay? 4x squared. Sorry, I had a technical problem there. I had to stop the video. We're going to continue on. So we got a 4x squared in the numerator. So then we're just going to combine like terms or see what we can do. So we'll arrange them in descending order of the power. So 4x squared will be first. We're going to multiply this out. We have an ax, and then we have an ab. Okay, that is going to be our new numerator. And then in the denominator, the book kept it in this form. You could multiply it out, but both terms would have an x common, so it's typical more to factor out the x. Okay, this one doesn't have a common term that we can factor out in the numerator, so that's why we expand it. Okay, they don't have a number we can take out. We don't have an x we can take out of all three. We don't have an a or a b that we can take out of all three, but we can down here, both of those terms. Okay, if we multiplied them out, it would be x squared plus xb. So it's typical to go ahead and factor out the x in an x plus b. So this is our answer for solving, simplifying complex fractions with numbers and variables combined. So again, gravitate toward the most complicated area, simplify that area first. Okay, get rid of the fraction in the denominator by multiplying by the reciprocal. Then it's just simply combining like terms, multiplying things out, and coming with a more proper format. And what do we have? A simple fraction. One expression in the numerator, although it's rather long and more complicated, you could say, than any numerator up here, but it's only one expression in the numerator, and we have one expression in the denominator. We only have one fraction line. Okay, so I hope that helps. Shoot an email or a text message with any question on your Algebra 2 homework. So long for now.